Okay, so this is programming in Java. Okay, so we are in the module 4. In the module 4, we have two parts. One is packages and interfaces, and the second is the exceptions. So we are finished with the packages and interfaces till the last class, and now we are starting the second part, which is the exception. And within the exception, we have the outline as shown here. Okay, exception handling fundamentals or basics. Then the types of exceptions we have. Then what are the Java built-in exceptions, default, built-in exceptions, and how you can create your own exceptions. Okay, these are basically known as the manually created exceptions. These are built-in exceptions are what are known as runtime exceptions. Okay, built-in means Java has inherently some of the exceptions, and those corresponds to the built-in or the runtime exceptions. Okay, so we will try to first, today we'll try to go through this, and might be, if time permits, we'll go through the types, right? So very few of the types you might go through, and then we can have it in the next class, the rest of the, what you call part. So exception handling in Java is one of the most powerful mechanisms to handle runtime errors. Basically, whenever we talk about exception is basically a runtime error. Okay, so exception handling in Java is one of the most powerful mechanisms to handle the runtime errors, so that normal flow of the application can be maintained. So even if a what you call runtime error occurs, then we should be able to smoothly go to the next part. Okay, leaving the by trying to handle that runtime error, and rest of the program we can continue doing the same. Okay, so normal flow should continue even though errors occur. Handle the error and then continue in the normal way as if nothing has happened, but give an indication that the error has happened. So an exception is an abnormal condition that arises in the code sequence at runtime. So exception means abnormal condition which occurs during the code sequence is running at runtime. So in other words, exception is a runtime error. Exception is a runtime error. So in the computer languages that do not support exception handling, errors must be checked and handled manually. So many languages which were before Java were not having the exception handling mechanisms, so errors must be checked and handled manually. Whereas in Java we have a proper built-in error handling mechanism, typically through the use of error codes and so on. In the earlier languages we had error codes, and might be some other methodologies to handle the errors and exceptions. Whereas Java exception handling avoids these problems, and in the process brings runtime error management into the object-oriented world. Okay, Java is basically an object-oriented programming language, and it brings it uses what is known as the exception handling mechanism, so that the runtime error management can be done. So Java exception handling provides runtime error management. So Java exception is an object. So whenever a exception occurs, then automatically it means that an object is of the particular exception is created. Okay, an object of the particular exception is created. So Java exception is an object that describes an exceptional, that is error condition, that has occurred in the piece of code. Okay, error condition that has occurred in the piece of code. So when an exceptional condition arises, an object representing that exception is created and thrown in the method that causes the error. Okay, as soon as the exception condition arises, the object that represents that exception is created, and we generally call it as thrown in the method that caused the error. Method just means the function where it has occurred. Okay, we know that Java has basically methods wherein we do some type of implementation of the code, and there if the error occurs, and it will just what you call the exception is created and thrown in that particular method, and it will be indicated that the exception has occurred in that method. Going further, okay, before going further. So that method may choose to handle the exception itself. The method itself might choose to handle the exception itself or pass it on. Okay. So either way, at some point, the exception is caught and processed. We see that, the exception is either handled by the method itself or it can be passed on to some other method. But however, we see that the exception is caught and then, handled. Okay. So whenever exception is thrown, it is caught and processed by the Java system either way. Okay. If manually, if you are not able to do, then it will be able to handle by the built-in, Java built-in exception handling mechanism. Okay, so exceptions can be generated by the Java runtime system also. Okay, exceptions can be generated by the Java runtime system also, or they can be manually generated by your code. Okay, might be that the Java runtime system itself might generate an exception, but also there is possible that you might make some errors because of which the your code might generate the what you call exception. So exceptions thrown by Java relate to fundamental errors. The exceptions which are thrown by the Java runtime system correspond to the fundamental errors that violate the rules of Java language. Okay, that violate the rules of Java language or constraints of the Java execution environment. Whereas manually generated exceptions are typically used to report some error condition to the caller of the method, and this is basically the mistakes done by the user. Okay, mistakes done by the user. So manually generated exception means that might be that the human being who tries to write the program, right, create some type of errors in the methods, and those will generate the exceptions. So exception handling mechanism has 5 keywords, right? So it has the 5 keywords: try, catch, throw, throws, and finally. So first we have the keyword try. Okay, so we generally, if we feel that a particular code might create a exception, then we keep that code within a try block. Okay, so program statements or block of code that you want to monitor the exceptions are contained within a try block. So within the try block, we put a block of code which can create an exception, and we keep monitoring. Once we put in the try block, then that will be monitoring whether an exception occurs or not. Then we have catch. So as soon as the what you call we put it in the block, then might be that a exception is thrown, and once the exception is thrown, it should be handled, and the handling of the exception is done within the catch block by catching it. So if an exception occurs within the try block, it is thrown, and your code can catch this exception using the catch keyword and handle it in some rational manner. Okay, if an exception occurs within the try block, it is thrown, and whatever our code is there can catch this exception using the catch keyword and handle it in some rational manner. Okay, handle it in some rational manner. Might be indicating, it might be just an indication that it has occurred. If the particular error has occurred, and if the code has to continue, then it might assign some values to the variables which might have created the error. Okay, then we have the throw. System generated exceptions are automatically thrown by Java runtime system. System generated exceptions are automatically thrown by the Java runtime system. To manually throw an exception, use the word keyword throw. So this is manually, throwing an exception. Okay, throw means, okay, manually throwing the exception. Okay, then we have, sometimes it might be necessary, we'll see why we need to throw manually the exception. Wantonly we might try to create an exception, and that is throwing an exception. Then we have throws. An exception that is thrown out of a method must be specified as such by a throws class. Okay, so might be that a particular method, there's a possibility that what you call it can throw an exception, and therefore we try to write here throws at that time. Any exception that is thrown out of a method must be specified as such by a throws class. Possibility of the throwing. What throws just means a method. It's possible that a particular method might throw a exception at that time. We use that. Then we have finally any code that absolutely must be executed after the try block completes is put in the finally block. So as soon as what you call a either way, that is whenever a exception occurs, then the exception is caught and it's handled, and then say if we have to totally come out of the system, then whatever is there in the code finally also is handled. Okay, this is just to see that smoothly we come out, and some of the things in the finally might be associated with something like closing the objects, which might smoothly going to so as to go out smoothly out of the code. So finally is the code which will definitely be executed. Whatever is put in the finally keyword, finally block, we can say finally block is should be executed even if a so to say exception is thrown and handled. Okay, exception is thrown will be corresponding to whatever is there in the try block. Once an exception is thrown, then it will be caught and handled within the catch block, and then so that if we need to terminate, before terminating, finally should definitely be handled. Okay, the code within the finally block should definitely be handled. So the general form of the exception handling block will be something like this. Okay, try within the braces. Okay, braces are necessary over here. Okay, block of code to monitor the errors. Then you have catch exception type 1, the object associated with that. So what is the type of exception which can occur, which should be caught over here in the catch block is being mentioned over here. So if multiple exception what you call types are there, then you need to write many catch blocks. So for each type of exception, one catch block will handle it. Exception handler for exception type 1, and then catch exception to exception object, exception handler for exception type 2. Okay, so this will be each of the exception. If you have again 3, we can keep on writing like that. So there might be many catch blocks for each of the exception type which might occur. Then you have finally the block of code to be executed after the try block ends. So once the try block ends, this final block should definitely be executed. So here exception type is the type of exception that has occurred. Then we have the different exception types. So in Java, everything is a class, right? Therefore, we have here a exception hierarchy as shown over here. So at the top, we have throwable. Then the throwable has 2 children, exception and error, and the exception itself has a child, which is the runtime exception. We'll see what each one of this corresponds to. So all exception types are subclasses of the built-in throwable. Built-in throwable, whatever is there here is a throwable is a built-in class. Okay, so all the exception, what you call types are subclasses of this throwable. Okay, it should come through this. So this is the default, so to say, exception class. Okay. Throwable partitions exceptions into two distinct branches using two subclasses. One is the exception class and another is the error class. Two children. Okay. Exception class used for exceptional conditions that user programs should catch. These are exceptional conditions that user programs should catch. To create your own custom exception types, we use the exception class. Okay. So if we want to create our own exception types, then then we can use the exception class. So there is an important subclass of exception called the runtime exception. Exceptions of this type are automatically defined for the programs that you write and include things such as division by zero and invalid array indexing. Okay, this is an important subclass of exception which is known as runtime exception, and exceptions of this type are automatically defined for the program that you write and include things, whatever we try to write the program, then for that runtime exception is a type which is automatically defined. And this includes the division by zero or invalid array indexing. So let us take a small code of how we can to find out what is the type of error which might occur. Okay, what happens when you don't handle exceptions? If we don't try to handle exceptions, what is it which is going to happen? So in general, even if we don't handle the runtime, system will handle the exception at the end. So this small program includes an expression that intentionally causes a divide by zero error. So we have written here a class exc0. Within this, we have written the main method, public static void main string args. Then we have created a variable d of the type int, and it is assigned a value 0. And then we have created another variable a of the again type int, and to this is assigned the value 42 by d. Now this value of d is 0, so we'll get 42 by 0. The 42 by 0 is a what you call infinite value which cannot be indicated, and hence it's a divide by 0 error. Okay, so when the Java runtime system detects the attempts to divide by 0, so this error is detected by the Java runtime system. So detects the attempt to divide by 0, it constructs a new exception object and then throws this exception. Constructs a new exception object and then throws this exception. This causes the execution of the exc0 to stop. Because once an exception has been caught, has been thrown, it must be caught by an exception handler and dealt with immediately. So in this example, we haven't supplied any exception handler of our own. So the exception is caught by the default handler provided by the Java runtime system. Okay, the exception is caught by the default handler provided by the Java runtime system. So any exception that is caught by your program will ultimately be processed by the default handler. If we don't process on our own, then it will be processed by the default handler. If we provide a code to handle that particular exception, then it will be handled by that. Otherwise, it will go straight away to the default handler. So default handler displays a string describing the exception, prints a stack trace from the point at which the exception occurred, and terminates the program. Okay, default handler displays a string describing the exception, prints what we call a stack trace from the point at which exception has occurred, and terminates the program. Okay, so how the stack trace will be there, that's what we have over here. Okay, here is an exception generated when this example is executed. So we are having the same thing over here, divided by 0, 42 by 0 will give us a what you call exception because it's a divided by 0, and there it will indicate java.lang.arithmetic exception. Okay, divided by 0 at exc.main exe.java, then :4. So what does this indicate? Now this gives you the program name. exe0.java will give us the program name or file name, and within the file, the 4 indicates the line number 4. So 1, 2, 3, 4. Line number 4 is, so it's occurring here, and this is the line number 4. 1, 2, 3, 4 in the what you call file where this code is present. Okay, exe0.java 4 will give you the file name and the line during which the exception has occurred, and this is there in the exe0.main. Okay, it is there in the exe0 is the class name and main is the method name within which this error is occurring. So this is the class dot method name within which the error is occurring, and this is the file name and the line number. Okay, line number. So we will do it. We'll finish it within 2 minutes, right? So the same thing is being indicated over here, right? The simple stack trace for this program includes class name exe0, method name main, file name exe0.java, line number 4, and type of exception thrown is arithmetic exception, and then we have the divide by 0. So Java supplies several built-in exception types that match the various sort of runtime errors that can be generated. Okay, that can be generated. So that is what we have. That's again the same thing over here in a different way, only that we have written here a subroutine, and within the main we are calling the subroutine. So it will indicate the what you call class name exe1. There might be an error E over here, whereas it is C. Method name, it is occurring, what you call within subroutine, and that is called through the main. So therefore, method names associated with that exception, main and subroutine. File name, it is exe1.java. Then line number, this is 7 line number, and this is 4 line number. That's indicated by 7,4. And type of exception, arithmetic exception. And at that time, for this program, it is going to give the error like the java.lang arithmetic expression divided by 0 at exe.subroutine, exe1.subroutine, exe1.java 4 at exe1.main, exe1.java 7. Okay, so and subroutine, this is line number 4 in the file. Main, the error is occurring for the subroutine, and that is line number 7. So the call trace is quite useful. This is known as the call trace, okay, or stack trace, whatever you call it. The call stack is quite useful for debugging because it pinpoints the precise sequence of steps that led to the error. So how we can use the try and catch block, we will see in the next class, right? So we'll end the